This is the underside of the cathodic protection simulator, which represents the underground components of cathodic protection and shows how the electrical charges are distributed from the source, the power source of the energy, which in this case is a battery, which is controlled by a variable resistor, a potentiometer, and the charges come from that into the ground bed, which is represented here by a complete bank of resistors soldered together that together connect to remote earth, which is on the other side of this board. The charges, by the time they have got from the ground bed anode through to remote earth, are distributed everywhere throughout the earth. That is, everywhere in the world. Now, those charges return to the pipeline at coating faults. And on this simulator, we have 3 pipelines represented by these bits of copper wire, and a capacitor is built into the system so that it represents the capacitance of the whole system, which is what we find in cathodic protection, and that is the reason why when we switch it off, it gradually decays and it does not drop immediately, because the whole system has a capacitance. Each of these lengths of pipeline is joined to a variable resistor, and that represents the coating condition, which can be adjusted. And in this pipeline, we have 2 resistors that join the sections of the pipeline, and they can be adjusted to adjust the simulated length of this pipeline, which is also made possible by the resistors in this circuit here, this part of the circuit here. So the charges that come to this pipeline, this end of the pipeline, there will be a resistance to that end of the pipeline of the equivalent of about 70 miles. So this pipeline is 70 miles long. This one could be a short pipeline, probably of, I don't know, a couple of miles. This one is capable of being adjusted to about 30 miles from 1 mile. And the whole system is simulation of the actual electrical properties that are in a normal cathodic protection impressed current system.